Good morning. We are starting this subject, which is object-oriented programming in Java. Now, initially, we are going to discuss what you mean by object-oriented programming or object-oriented programming concepts. So, before discussing that, you should be you should know what you mean by the conventional programming style. In earlier languages like C, COBOL, Pascal, etc., there we are not using object-oriented concepts. There we are using conventional programming concepts. That means you have a set of instructions. That means you have a main program and you have a set of lines or set of statements, and that is executed in line by line. And after that, the output will be printed on the screen, or output will be displayed, or some task it will do. That means you have a set of inputs, you are processing that set of inputs, and finally you get a set of outputs. That means that is called conventional programming. But when we are dealing with real world, real world, every entity, whether it is a house, whether it is a human being, whether it is a cow, whether it is or whatever it be. For example, this is a pen and pen, pencil, everything. This all means in the real world you have a set of objects. You have a set of objects, and as you know, in object-oriented programming, the most important concept is the set of objects. That means an entity. For example, a classroom. Classroom is an entity. A student is an entity. Teacher is another entity. That means whatever you see in this real world, if it is an object, that means if it is not suppose that somebody is walking, that walking is not an object. So it is doing something. That means whatever you see in the physical world, that is an object. That means in the real world, every objects interacts with each other. Every object interacts with another object, and we want to have a programming style which we call as object oriented programming. That means in object oriented programming, we consider every entity as an object. Every entity as an object. And for example, suppose that you have, say, a student called, say, Anil is a student, and suppose that student belong to a class. For example, Anil is a student, then Manpreet is another student, then Joseph is another student. That means these are all students. That means here we have a set of students. These are a set of students, and so these students belong to the same class. For example, if you have, these are all students, that means Anil is an object. Anil is an entity, so Anil is an object. Then Manpreet, she is also a student, that means she is also an object. Then Joseph is another student, he is also an object. Okay, now these three students belong to the student class. That means these are objects, and these objects belong to the class. The class name is student. Class name is student. That means, for example, every student is such as a student has a number of properties. Student class. For example, suppose that I am going to have, say, name. What are the properties of students? Properties of student. Number one, he or she has a name. That means every student has a name. So name is a property of the student. Now every student is having a roll number. Then suppose that she is having date of birth, etc. So now we are focusing only on these three properties. So you can have any number of properties for a student. For example, register number, then year in which he or she is joined, then parent name, etc. etc. That means you can have any number of properties you have to include. You can include. Okay. So this is called class and object. That means every real world entity which you can see is an object, and you can group your objects into a set of classes. For example, you can't see the class student, so this is an object created from this class. That means this is a particular instance of students. That means Anil is a student, Manpreet is another student, and Joseph is another student. That means all these three objects belong to this class. Belong to this class, and this class is having certain properties. That means these are the properties of. For example, a student has got a name, then she has got a roll number and date of birth. Okay, that means that means in the real world you have a set of objects. That means everything is an object. Okay, then when you are classifying this into a set of classes, for example, suppose that you have a peculiar plant. Say, suppose that you have a mango tree, then you have another, say, then apple tree, orange tree, etc. That means this apple, orange, then or any tree that belongs to the class tree. Okay. For example, you can have another class, say tree. What are the properties of trees? Properties of tree. A tree, you can have different properties like, say, height of the tree, um, thickness, etc. etc. Then if it is, whether it is giving fruit, that means whether it is giving fruit, etc. etc. That means a number of properties are there for this tree. And suppose that you have a tree, say different objects that can be created from this class tree is mango tree. Mango is a tree. Then jackfruit is another tree. Then say apple, orange, etc. Those are all trees. So, in real world, whatever you see is an object, and you can classify your objects into a set of classes. So, if you have a class, then that class has a set of properties, and then these objects can do something. For example, a student can walk. He can run, he can listen to, he can read, he can write. So these are the methods. That means these are the methods. That means, or these are the functions. That means a student can walk, then he can run, he can read, and he can write. Okay. So when we have a class, if you are developing a class, that class has got a class name followed by a set of properties and yet a set of functions. That means what the object can do. That means it's a verb. That means what the object can do. For example, if you have, say, pen. Pen is an object. Pen. What does this pen do? Pen can write. And what are the properties of this pen? The color of this pen. What is the color of the ink? Then what does the then uh, what does this do? It can write. Okay, it can write. So when we are talking about a class has got a class name followed by a set of properties. These are the set of properties associated with this student, and this student can do these functions. Okay, then another example, this is a class tree, and tree has got some properties, and whatever the tree can do, what does a tree do? For example, a tree can, these are the functions that a tree, that means it can flower flower, then a tree. So whatever the tree can do, those are the functions of that tree. Functions of that tree. Okay. So as a whole, the main property of object-oriented programming. These are the different properties of object-oriented concepts. These are the important properties of objects, and in at this point in time we are focusing on classes and objects. Class means you can classify or you can have a group of objects which is satisfying or which are sharing some properties, and that is called a class. And class has got a class name, and it has got some properties, and it can do something that is called functions. So this is the representation of a class. This is the class name followed by properties, and this is functions. That means this is name of the class. Then these are the properties of classes, and these are the functions that can be done. Functions, otherwise we call it as methods. Methods. Okay. Then you have a set of classes. Here you have a student class, and here you have a tree class. Then an object is a particular instance of the class. Suppose that you have a student named Anil. When you are creating this Anil, then Anil is an object. Okay. Then Manpreet is another object, and Joseph is another object. That means the real world object, actual object is created from a class. Actual object is created from a class, and classes the general one, and object is an instance of that. Okay.